Hello, this is the Blast Report podcast on all things blasting. My name is Evan Thibaud with Pneu Wave Consulting, and I want to thank all the drill and blast teams along with those supporting them who are out there on the pattern. The production team at Blast Think and I would like to welcome you to today's episode of the Blast Report podcast. This episode is brought to you by Pneu Wave Consulting, where we bring innovation to industry. Our goal is bridging the gap between those who create technology and those who are in the field every day looking for improvements in safety, productivity, and reduced environmental impact. Our goal is to help customers with training, audits, and blast design to get the job done right. We do this by joining your team to achieve your goals. Contact us today at newwave.com. Okay, so Joe Stobbe, welcome to the Blast Report podcast. How are you doing today?
I'm doing fine.
Thank you for agreeing to come on the show.
You bet.
Now, Paul Sturck was the one who gave me the hint that you'd be a good person to interview, and he didn't really give me too much of your history or anything like that, which might be a good thing or a bad thing. But how we normally like to start the show is to just get kind of an origin story on who is Joe and how did you become a member of the blasting community, and what piqued your interest into blasting, and if that was something that you can share with us.
Certainly, and I make kind of a joke, but it's reality. I grew up in south central Montana on at that time it was a medium-sized ranch, and we wintered cattle on the Yellowstone River. And it's like I tell everyone, I got tired of chopping ice for those cows and found a better tool, that being dynamite. To put that in perspective, this takes us back into the days when you would, if you needed dynamite, you would simply go to the hardware store, and the dynamite was stuck back by the bolt bins in the back room, and the detonators, which were at that time the red and white DuPont electric blasting caps. They were behind the counter. So it wasn't a big deal. It was like buying any other tool. And what I was fascinated with was the amount of energy that is delivered at that time by dynamite, and found it to be a very effective tool. And I did a lot of what would be termed agricultural type blasting. In those days, beaver dams, drain ditches, actually shooting trees, big old cottonwood trees out for clearing land. It did a much better job than conventional methods.
Interesting. So it would just be like in the winter, the peak of winter, and these ponds would be frozen. So you'd go in and drill a little hole in that pond and shoot that ice so that the cattle have something to drink. Is that how it worked?
Yeah,
Okay.
yeah. The Yellowstone River, especially when it was bitter cold, would raise and lower sometimes 2 or 3 feet overnight, and leave you cakes of ice that were 20 inches, 2 feet thick, and large, and a lot of them. So it became quite a challenge getting water.
And was that it was like access to the water? You didn't want the cattle walking out on the ice, right? Is that kind of the reason?
Yeah, they just simply wouldn't do it.
Oh, they wouldn't even. Yeah, they wouldn't mess with it. They're smart creatures. Those.
Yeah.
Okay.
But after that, I started working as an independent. I worked for a small Gulf dealer at one time, and Gulf Oil Chemicals actually made explosives back in early 70s.
So you felt is it because were you a ranch hand originally, or that was like a family thing?
Yeah, it was part of the family ranch.
Okay, and at some point the powder factor of beaver dams was not interesting you anymore, or?
Well, it was a chance to expand my horizons, and I got into doing some rock blasting and things like that. And then the oil fields, shooting locations for a new oil well.
In the grid pattern, so that they could they could do like seismic locations of where the oil is?
No, they'd already made their decision that they were going to drill a hole, but a lot of times, that might be in the side of a hillside. And so that entire 3-4 acres had to be flattened and leveled. Additionally, where they put the mud pit, that had to be in virgin ground. It couldn't be part of a fill. So there was a fair amount of blasting to get a site ready to drill
Interesting.
a well.
So I guess you would be doing access road, and then could you go into that a little bit more? I don't know anything about that.
Yeah, it depended on where they were at. Sometimes it took some drill and blasting to even get to the location. And then again, the location itself was typically 4 or 5 acres, and it had to be pretty flat. So there was a fair amount of blasting involved. And then if they were successful, typically there was a pipeline put into what they call a tank battery, where the oil would be stored until it's hauled off. So it was pretty good. And I started doing a fair amount of demolition at the same time, because it pays well. And
it sure does, huh?
Yeah. But in the late 80s, mid 80s, the insurance companies got so tough on, especially the small guy.
Yes.
And so I had thought about just getting completely out of it. And one of my suppliers, they were both Atlas suppliers at that time up in Montana. One of them told me, he said, well, we're the group in Spokane, they're looking for a tech rep, and you ought to apply, which I did. And I went to work at that time for what was Ore Yard Powder. And Hugh Oryard was a true gentleman and a true scientist. I was very fortunate to be able to spend about 3 years with Hugh. And then I took a transfer to the Southwest for Atlas Powder Company.
Wow. And so what was Hugh doing up there? Was he doing all types of blasting, or what was?
He was a supplier and again, a scientist. He developed a lot of different products. Hugh's family, I think, and Hugh was probably in his late 60s, early 70s when I worked with him. And he was the third generation of ore yards that their beginning actually started in the early 1900s. In fact, right at the turn of the century. And at that time, they were handling a lot of black powder because there was 3 or 4 railroads that converged into Spokane. And if you know anything about Western Washington, it's all basalt, which you're not going to rip it. It's going to be black.
Yeah.
Yeah.
And Spokane's quite a hub there.
Yeah, it was. And Hugh actually, he and a partner developed what they call WR powder, which was guar gum, coal dust.
I've used it. Yeah. Interesting.
Yeah.
Share some more about that, because there's not a lot of people who get to use that, actually.
Well, I was always, the first time I saw it, I was very skeptical. We got into a very wet quarry, which isn't unusual out there. And you would blow the water out of a hole and then go down with this stuff. And it actually formed a jelly.
It looks kind of gross.
Oh, and it's slimy and it's nasty to handle.
It sure
And it's
is.
wet.
Yeah.
Because it's war gum.
Uh-huh.
And it was a batched process, as I remember right, about 3,000 pounds at a time. And it was batched in a mixer type a setting and then bagged.
This is all
And it was
before
actually,
this is all before emulsions. This is how you
yeah,
this is how you put ANFO in a wet hole, essentially, right? If you
exactly. And it actually had more energy than straight ANFO for some reason.
Okay.
And and worked very well. You probably used it with the Sheeran brothers out of Ohio.
I had worked for Maxim, and Maxim had a plant in West Virginia that was bagging WR.
Okay.
And it was the guar gum, and I saw it used at a few sites because I was initiations and package product manager for them in North America. So I was traveling around all over the continent, seeing the different applications. And I don't know many people who use the WR. They pretty much just switched to emulsion chubs or something like that. But it's very unique to see that can you explain how it reacts? I mean, it's the guar gum reacts to the water, right?
Right. And basically creates a seal. The seal was very strong. It probably only took up about a quarter of an inch of the circumference of the borehole.
Right. It's the outside. It's whatever comes in contact with the water, and it doesn't impact the inside, right?
Right. And what you always had to come out of water with stick powder. I mean, some of those holes, they didn't dry out very well, but
True.
you would start down with a semi-gelatin dynamite until you're out of water, and then typically we would drop the higher energy, which was typically an ammonia gel, like Power Primer. At the time, it was called Power Primer, and then you would start pouring the WR down.
And that WR would kind of fill that little gap between where the sticks wouldn't couple.
Right.
And it would give you like a floor almost of ANFO, right?
Mm-hmm.
And then whatever was above that would stay dry unless there was some residual or some static or some dynamic water that was coming in through a void, right? And then that would kind of cut that off.
Right. But your entire borehole, once they've blown them out, the entire borehole is wet. The sides of it.
Yeah, good point. Yeah.
So once you started with WR, you loaded all the way out with that. So, and it worked very well. And
so he
like
developed that, huh? That's cool.
Mm-hmm. He and a fellow by the name of Hal Sheeran, they were very close friends and extremely bright people. And he had actually developed another product. They actually called it Verilode for pre-splitting. And it was styrofoam beads and ethylene glycol, same thing, antifreeze, and as your fuel, because diesel fuel will eat the styrofoam beads, right?
Yeah, any kid who wanted to make napalm in the backyard learned that project.
That's right. And so he had this product that you would fill the entire borehole for pre-splitting, and it worked very well. But the transportation was, you would fill an entire semi load and you maybe get 10,000 pounds. So the cost of transportation,
because it's so lightweight.
Yeah.
And selling by the pound, it didn't make a lot of sense.
No.
But did it burn? It burned, or it would detonate?
It detonated. It was probably pretty low, probably in the 6,000-7,000 feet per second range, just above detonation.
And just enough to what pre-splits needs. I know that there's different products out there that people are saying that a low detonation velocity is actually all that's needed for pre-splitting. Is some of the newer studies, but you got to watch out your critical diameters, but decoupling is good, but then you get down to critical diameters, so you have to worry about what kind of product you're using. But that's interesting. So this was a fully coupled styrofoam mixed with antifreeze.
Mm-hmm.
And it was like regular pelletized styrofoam, like the stuff that you would see that they've...
Yeah. That and ANFO, of course.
And ANFO, okay.
Yeah, and ANFO was the main ingredients.
Okay, I see what you're saying.
Yeah.
I was thinking for a second you were talking about just...
No, not just styrofoam. No, it's not going to do anything.
Yeah, okay. I was like, whoa, just burning a hole through everything. Interesting. So they were really, Hugh and his partner, they really enjoyed the science behind it and practicing
and Hugh
technologies.
He was truly a scientist. I've been very, very fortunate in my career to have been given the ability to work with some extremely sharp people that are scientists. The last 30 years I spent with Tom Frederick Sr., who too is a scientist, and he was the original president for WESCO, Western Explosive Systems, in the West. And I just left those folks, finally retired at the end of last year.
Did you really? Congratulations.
Yeah.
You bored, or are you doing all right?
I'm doing okay. I created an LLC, and I've always enjoyed training, and I've done some training and done some work just over the phone with some people.
Perfect.
That I've worked with in the past. The people I work with, I still get calls. I think part of it is just see if I'm still kicking, and they'll always throw some question that they probably already have the answer to, but it's to humor the old guy.
Yeah, you're nicer to yourself. They definitely they need some help. They need some assistance. It's really nice to have someone with a little bit of gray hair to confirm if you're doing something smart or if you're doing something stupid. That's for sure. There's a lot of people, like you said, they got the question, they got the answer themselves, but they want to know if that's a good answer. There's a lot of value in that.
I think there is. I always reached out to people, and like I said, I've enjoyed the training. I again was lucky in being able to go to Mike Barber's when I was with Atlas. Mike Barber was the head of field technical operations for Atlas and put on the best schools that I'd ever been involved in. And I've always tried to emulate as close as I could to the quality of what Mike and his people put on. And I don't think I've ever achieved that, but it's certainly something to shoot for. And those were good schools. They were typically 5 days. You had 4 days of real intense class. And then on the 5th day, you had about a 4-hour test. And in many ways, it kind of dictated your future within the company as to how well you did.
And these were the initial tests to get your blaster's license?
No, just an internal test for Atlas to determine the quality of the people that's out there.
That's an interesting method, and a nice way to start people off, to be able to say, all right, if you're going to be on the pattern, you need to learn this amount instead of spending 2 years as a blast helper following people around. It's nice to have experience, but it's also nice to get some classroom fundamentals.
Oh, absolutely. And I remember I told you I left Spokane for the Southwest, and that was part of my interview is when I went to Dallas to the headquarters for the interview for this job in the Southwest, the vice president opened up a folder and said, "Boy, you've really done well at the tech schools." And I'm going, "Wow, I was just working my tail off for me to learn. I thought it was a wonderful opportunity, but yet it was also part of your portfolio."
Yeah, and your reviews later on.
Yeah.
Wow. And so what year was that you had moved over to Atlas?
I moved from Oryard, would have been 92.
And was that a
91,
big shift going from, like how, tell me more about Hugh and how he went from like being scientific, and was that a fairly small company working for Hugh, family run, and then going to Atlas? Like was that transition pretty fluid, or how did that work?
Hugh was actually a part of what they called Western Energy, which was a part of Atlas already. It was jointly owned between Hugh and Atlas, and they run under the name of Western States, and Oryard was a part of Western States. So it was just basically an intercompany transfer.
Okay.
And I went from shooting in quarries and road construction, a lot of road construction and rock quarries, to when I got to the Southwest, then coal was a big item. And so that added a whole new dimension to my world.
Yes. Was that an interesting shift to move from construction to coal, or was it more of a kind of a relaxed moment? Because not to downplay coal blasting or anything like that, but construction is just so fast paced and variables changing constantly that was that something that you were like, okay, these are a lot bigger holes, there's a lot less variables, but you got to really pay attention to what you're looking at now or something? How did that work for you?
Well, what was with the coal, if you're dealing with just inner burdens between seams of coal, that was pretty straightforward. Big holes, like you said, in kind of meatball surgery. But then the casting became a big issue, and that's where there's a lot of big dollars tied up, and the science behind cast blasting is still fascinating.
Mm-hmm.
And that's where I was introduced to laser profilers and high-speed cameras and that kind of thing, to where you were actually looking at your criteria was the face velocity of the rock, and that would dictate your cast percentage. And oftentimes, when you're dealing with 1 or 2 million pounds going off, and you're dealing with about the same amount of quantities of rock, if you can increase cast percentages even 3 to 4%, that's big dollars. And so that became kind of a fascinating science too.
Now, was cast blasting around, or was that new at the time? It's actually been one aspect of blasting that and underground coal. I've never blasted an underground coal with permissibles, and I've never really done much cast blasting. Did one professionally. So can you kind of explain, like, what's the history of that?
Well, everything ties back to money. And this, I would imagine, really got going in the mid 80s, I think. And that a couple of the mines that I was dealing with down here, at one time, there was literally 6 or 7 coal mines in my region. And they were all going to cast blasting for the obvious reasons. For every yard of material that you throw into its final resting spot, equipment never touches it. So
you're saving
that's
millions of dollars.
Literally. And so it's not only the load, it's the angle of the hole, it's the timing is critical on this stuff. And
this was with non-electric detonators or still with electric detonators?
No, coal was always non-electric or cord.
Or cord, okay.
Yeah, because you got those big extension cords going to either shovels or drag lines that's carrying 25,000 volts. And if you got any of that leaking into the ground with electric caps, that's not going to work very well.
Very good point.
Yeah.
And so this was initiated, was it surface trunk line, or did the down lines even, it was det cord until non-electrics came out? Probably, right?
Yeah, it would have been down line even with cord. Well, with a 10 5/8 inch hole, the damage from cord isn't as significant as it would be in a
smaller,
a 3.5 inch hole,
right.
Obviously. The non-electrics really helped. Of course, today, what has really increased is the electronic.
Yes.
Because the cap scatter in non-electrics is a lot more than we think.
Right.
And all the powder companies, I've put high-speed film to it, as well as using the microtrap from MREL, to test the velocity.
There you go. We got a sponsor now for the podcast.
Yeah. Do you? Well, that's a great group up there.
Yes.
They've been very, very helpful. Bill's a friend of mine, and
Cindy knows her stuff.
Yeah. But if you look at the x-axis on the graph, that's time, and you can see all the sins of the non-electric.
Absolutely.
And when you confront the powder companies, and we all have, their patented answer is, well, if you need a more accurate cap, go to electronic. So that's where we're at today. And the electronics have proven themselves in cast blasting. Absolutely.
Yeah, when I was a student, there was lots of communication, because it was kind of in the height of when electronics were being implemented after some field tests, and so I remember seeing a lot of nice presentations on using computer simulation to simulate cast blasts, and to use electronic detonators, and to see, going around the 8 millisecond rule to get more sonic velocity. But I never really knew what the origins of it was, or who the first guy who was saying, well, why don't we just shoot it so hard that it goes across the pit? I feel like whoever the first person was who invented that really had the balls to tell his boss, like, why don't we just angle these holes and launch it? Like, I'm sure corporate was not happy with that idea originally.
No. Yeah, it would be interesting to know where it actually started, but I mean, it's commonplace now, and I think everyone, regardless of who the company is, has it pretty well dialed in, and it's site specific too. All the rock is a little bit different from, Wyoming is going to be a lot different than it is in New Mexico or Colorado.
Is it what makes those sites different? Is it just other than the obvious, like, types of rock? Is it other factors?
Well, you always have some environmental factors, because in cast blasting, typically you're going to get some orange smoke, and especially in Wyoming, it's a issue because the compressive strength of the rock is very low, and I spent 5 years up there at the NARM site as a manager
Oh, wow.
for Wesco. And I told my guys after coming out of here in New Mexico, I said, if this was a construction site, we wouldn't sell 50 pounds of dynamite because they'd rip it all, But because of the massiveness of it, that's why it was blasted.
Wow.
And
Yeah, wasn't
and the
NARM the
cast,
largest,
it is,
or still is the largest mine in North America? North Antelope
it
Rochelle
is,
mine?
yeah.
Wow. Now, there was a story of a school bus getting smoked out from some post-blast fumes. They happened to be driving down a county road, the school bus, and then there was a blast and the wind picked it. Did you hear about that situation?
No, I did not.
I
No.
believe so. It was a long time ago, but yeah, I remember as a student, we went up for the Best in the West conference from Rolla, and we went up there to visit and to learn, and that's a great conference they have up there. Wonderful conference.
It is.
And they would always set up tours for us, so we would try to get in a tour and actually see what we're studying in class and go look at something. And we had the opportunity to go stand in a bucket of a drag line. Unbelievable. Just really puts into scale what you're looking at. And we were supposed to see a shot, but the wind was in the wrong direction, so shot wasn't going off. That's it.
Yeah.
No questions about it. That was the rule. Shots going off tomorrow. So we didn't end up getting to see the cast blast that day, which it's when you get it dialed down, you think people know what they're doing, so it's really good.
Oh, yeah.
Was there any aspects to like coal standoff distances when you were loading, when you had to backfill through the seams?
Right. Oftentimes, depending on the drilling equipment, if they don't have real strong, accurate equipment, they will go ahead and what they call tag coal. In other words, they'll actually hit the top of the coal seam, and then the blasters will backfill 6-7 feet of drill cuttings before they start loading explosives.
Wow. So the reason they tagged the coal was so they could see the coal in the stemming in the cuttings, and then say, okay, we hit coal, we know we're at least where we're at.
Yeah.
Okay.
And then they got to get off of it, because otherwise you're going to pockmark that coal, or even literally move it out, and you're going to lose it. So, and that was more important down here where you're dealing with, 4 to 8 foot, 10 foot seams, where in Wyoming you got a 70-foot seam, so it's not as important, but they still do the backfill.
A 70-foot seam of coal.
Yeah.
Wow.
Yeah.
Oh.
Unbelievable.
Now, what dictated the 5 to 6 or 7 feet of backfilling? Was there some studies that proved, because I had a project where I was looking at some of this, and I went through some old ISCE publications, but I didn't know if anyone ever looked at, is it related to borehole diameter, or if somebody said, okay, well, eventually we're still getting dilution, and we got the least amount of dilution when we were 7 feet away.
It's probably that, as well as more important than the pattern. As more important than the borehole diameter, I would think, because you look at the angle of detonation on this stuff, and by going 6 or 7 feet off, again, rock is going to be dictating, that to a great degree, and it's whatever the dragline can handle. If you can tear that stuff out that's in the middle, then you're probably in good shape.
Yeah, if he's only got 7 feet of, pre-fragmented rock, but not blasted rock, then
Yeah.
he's got the power to do that. Okay.
Yeah, he can muscle through it.
Mm-hmm. And with a bucket size like those, I mean, it's pretty unbelievable in size. That's interesting. So were people setting the coal on fire, or they were just strictly worried about dilution?
Dilution. Yeah.
And in some of those, you said in Wyoming, the seams were a lot thinner.
No, in New Mexico and Arizona,
Oh, okay.
we see much thinner seams, and
Oh, right. Okay.
you're chasing multiple seams in many cases.
And you're decking through those, each one of those?
Usually, if it is a seam they're going to go after, they're just only going to shoot to that, and then after that coal's removed, you're going to take the parting, which is the rock between the two seams, and it's going to be shot. So it can be quite a complex situation there.
Oh, interesting. So it's it's a blast for each overburden. So you blast,
Right.
remove the coal, blast, remove the coal. It's not like you're blasting. I seem to remember a presentation. It might have been by Dale Priest or somebody, and they were utilizing decks, and they were shooting the top blast, letting that completely blast, and then they were shooting the bottom one, or vice versa. Do you seem to remember what I'm thinking of?
Yeah, Dale has done some real good studies, and it wouldn't surprise me that he'd come up with some new ideas. He's extremely bright. I knew him when he was in New Mexico working for Sandia Labs, so
ahead of time.
He's a bright young man. Yeah.
So this was all in your Atlas powder days, or this was when you
No,
were working with Hugh?
No, I left Atlas in '92 and went to work for Tom Frederick at Wesco, and my first assignment was NARM.
Okay.
And that was the spring of '93, and I was with him ever since. And we were in Gillette for 5 years, and then Wesco started to grow even more so down in the Southwest, and he'd gotten to the point where he needed a tech rep, and managing people. After 5 years of it's a burnout.
Yeah, it's different measuring powder.
Yeah,
tech reps.
I had 15 guys. We were at a rate at that time of about 5 million pounds a month, and I was doing it with 12 to 15 guys. And it's a 6-7 day a week project.
Now, I heard a story about a dress code. That was at Atlas Powder Company.
Yeah.
And what's the story there?
It didn't go well west of the Mississippi.
So is this one of the reasons why you went to Wesco?
Yeah, well, no, I pretty well maintained my my Levi's and a long sleeve shirt. I didn't show up in sandals, but I didn't show up in Dockers either.
Yeah.
Okay. And I told the lady, I says, I don't know how it works over here, but I said, you get on the other side of the Mississippi, people look and act different. And if I go out there looking like a prima donna, that's the way they're going to treat me. So they didn't push it too hard. I'll put it that way.
That's good. They wanted to worry about their image on the pattern. Is that the story?
Yeah.
Slacks and you were a blue jean guy, right?
I always was. Hasn't changed.
Yeah, it's true. It's kind of interesting when you show up to a new site, and depending on if your hard hat has some stickers on it, or if it's dirty, or if your boots are scuffed up or not, people definitely look at that real quick.
Yep, you're selected real well. The quicker you can become part of the crew, the quicker people are going to listen.
That's true. Yeah. Yeah, I drive a beat up little car as my road trip vehicle. So I have a Jeep Wrangler at home, but that doesn't work very well when I visit customers. You can't lock $6,000 4-hole deviation device in a soft top Jeep. So I drive this little vehicle around. It gets 45 miles to a gallon, and I'm whipping around to sites. It's great, but it's definitely not one that you're going to pull up to a pattern looking at and get any sort of level of respect. But then once they see that I'll pick up the down lines and use the stemming shovel and start stemming, they'll be like, oh, okay, maybe this guy does know what he's talking about,
That's right.
But it's pretty funny when you show up to, let's say, the national conference in blue jeans versus Best in the West in blue jeans.
Right.
Yeah.
And it can work the other way too. I had a young man over in Nevada, sharp and doing a good job, but had a hard time getting the big contractor's attention. And and I told him off to the side, I said, okay, we got a meeting tomorrow morning. I said, lose the piercing, show up with a collared shirt and a new pair of jeans. And as we went into the meeting, it kind of got started, and pretty soon I just turned it over to the young man that's there. And it was amazing how everyone kind of paid attention to what he was saying. He had valid points. And after the meeting, he said, I didn't think clothes would make that much difference. I said, well, there's your answer.
Mm-hmm.
He dressed for the occasion.
Yes. Yeah, and what about, did you see kind of, well, one of the things about the podcast is we're trying to retain some knowledge and some stories of people as they're retiring, right? And there's less and less of us replacing you guys. Have you seen some, I know I had a project out in I think it was Arkansas, where they sent me out there with a guy with some gray hair, and I was younger, and this was quite a few years ago, and I went and gave a whole presentation and everything, and I was the main person in charge, but the entire room went and looked at the man with the gray hair at the end of the presentation, and they said they looked at him, and he just sat there and then looked at everybody else, and they were waiting for his response, like, okay, what do you think? And he goes, oh, don't look at me, he's the one who knows what he's talking about, So it was pretty interesting just seeing that dynamic that obvious, right? I mean, it happens naturally. You're going to want a consultant who's got years of experience, don't get me wrong, but it's just really funny when it's just that blatant, when they just stop and they look at this one person and say, what's your, and he's like, no, I'm here to support, so that was Frank Sparks. So Sparky, Spark Plug, all power to him. Or no, not Frank Sparks, sorry, different Frank Sparks. Plug was his nickname. So it's pretty interesting. Now, one of the subjects that here in the podcast that we have is do you have any specific stories of a hard lesson that you would want to pass on? Maybe a near miss, or something that you can't read in the books, and a mistake that happened to you or happened to someone on a pattern that you were there for, and you were willing to share something that will maybe prevent someone else from making that same mistake in the future,
Yeah, well, probably one of the things that come to mind, it was a cast blast, And I won't say where necessarily, but it was under the control of the OSM, Office Surface Mining. And it was probably 120, 130 foot high wall. And it kind of come around a corner, the blast itself, and I was doing a high-speed film. About 2 weeks after the shot, I got a call from them, the mine, that the OSM was going after them because they had exceeded the overpressure limits. And so they said, didn't you film that? And I said, yeah. I said, well, let me go back to it. And I dug it out. And sure enough, as the shot come around this corner, there was about an 18-inch Ryder coal seam, which they just blow into the pit. They're not going to go after that. But I was able to, and it blew out the whole thing.
Into the pit.
Yeah, but the velocity was extreme. And I actually had the software that I could check the velocity. And normally with cast blasting, you want to see the rock moving somewhere between 60, 65 feet a second. That'll give you a pretty good cast, and that's where the acceleration curve is at. Well, I tracked that little coal rider where it blew, and it was over 100 feet per second. So it was screaming. So I went down to the Office of Surface Mining, and I showed them that film, and I said, because they were going after the blaster as well. They were going to cite him.
Take his ticket as well?
Yeah. And I said, I had it on a big screen, and I said, does anyone see anything wrong with his face anywhere? And they all looked around, and I said, no, it takes some time. I says, because this is what the blaster had to look at before he loaded. And then I let the film run, and they went, oh, now we see what happened. And they did vacate that.
Wow.
But it was just fortunate that we had actually filmed that particular shot.
Another reason why filming every shot is crucial.
Absolutely.
And hell, at multiple angles if you can nowadays,
Yeah. And a funny story, I told you I had about 12, 15 guys at Norm. And it's a young man's game. We all know out on that pattern every day, 10 to 12 hours a day, that's a young man's game. And the group I had were all young, tough kids coming off of ranches and whatnot. And I had two brothers, fabulous workers. They give you 110% every day. But with those two, every night was Saturday night, and every Saturday night was New Year's Eve. And one of them got to the point where he was late showing up for work. We always had the equipment started at 6:45. We left the shop at 7. Well, this guy is showing up at 5 minutes to 7, and then pretty soon it's 5 minutes after 7. And now I got the rest of them looking at me, like, hey, what's he doing here? And so I told him, I says, one more. I said, I'm going to give you 3 days off without pay. And he said, okay, boss, I'm sorry. About a week later, it's the spring of the year, we had all the shop doors open, and we could hear this high-pitched scream. And it just kept getting louder and louder. Pretty soon here, he rolls in on a popsicle green crotch rocket and parks it. And one of the guys said, well, how come you brought your bike today? And he said, well, I didn't wake up until 10 after 6 this morning. This is 65 miles from where work is. And I did the math real quick in my head. And one of the guys said, well, how fast will that damn thing go? And he said, I had her do 165 this morning. And the hair on the back of my head just stood up, Of course, I got him off the side and chastised him and said, don't you ever, I don't. You pile that thing up, I don't want it on my conscience.
Yeah.
These guys were tough, though. I would go to the wall for them every time.
Oh, I
They were
bet.
great people. Well, I would just say in leaving, a good blaster has a sixth sense, and trust your gut. If it doesn't feel right, there's something wrong. Go find out why.
Thank you for listening to this episode of the Blast Report podcast. I want to thank the team at Blast Think for producing this show, and please follow along for more episodes in the future, and share this podcast with your colleagues so we can continue to honor our industry and the people in it. Be safe and have a blast.